Okay, 6.2. And I said, there's two kinds of questions they're going to ask us, right? Things on the bottom line, we use the inverse norm. Is that what it's called, inverse norm? And things that we find up here, percentages, we use, what is it, normal CDF? Normal CDF. And whenever you do normal CDF, you have to put lower, upper, mean, and standard deviation. And when you do inverse normal, remember how that works? You've got to put left, mean, and standard deviation. So if you're going to do inverse normal, remember these are not a percentage. In fact, I should write that first. If you're trying to find the numbers on the bottom, so all these problems we're about to keep working on are all going to either ask us to find a percentage above, and that's normal CDF, or they're going to ask us to find something on the bottom that's not a percent. That's how you tell one from the other. The ones up in the curve are percentages, the ones on the bottom are not percentages. So, and what do we do? Remember, step number one, we have to find area to the left, and step two, use inverse norm left. Remember that difference? You see the one up above, the normal CDF, we don't care about left, right, whatever. We just put in lower, upper, left edge, right edge. They both go in there. You know what I mean? You could call this left and right, lower, upper, same thing. So for the normal one, we use left and right. We don't care. We don't need to be worried about anything. But for the one on the bottom that is not percent, inverse normal, we have to first find the area to the left and then go to inverse normal. All right, so let's get back to it. I'll refer to that again. I'll go back and forth with that. Let's, well, actually, you know what? Let's say, here we go, number 5. So our job is to figure out, do they want me to find percentages above or not percentages? Here we go. Engineers want to design seats in commercial aircraft so that they are wide enough to fit 99% of all males. Accommodating 100% of males would require very wide seats that would be too expensive. Men have hip breadths that are normally distributed with mean 14.9, standard deviation 0.8. So that's the average hip width, and that's the standard deviation, right? How much variation there is. Find P99. Well, now what's P99? That is the hip breadth for men that separates the smallest 99 from the largest form. So remember whenever they say P, they're going to do that a lot. P99 for anything. If they said, hey, you know, my newborn baby is at the 99 percentile weight. Actually, I still remember, it's because of that. My second child, my daughter, Emma girl, she is super, super tiny. And she was at the, she was below the 1 percentile. So what does that mean? That means percent below. In weight, she was like a feather. So the doctors thought she was sick, actually. That was 20 years ago, but they thought that was 21 years ago. But they thought, she just had her 21st birthday, they thought she had a problem. I mean, I appreciate the doctor. Doctor shipped us off to San Francisco with all those really sad, sick babies, you know? Anyways, it's just sad. I mean, I just feel sad. It's just a sad place to see. There's people that have real problems there. My daughter was fine. She was just a lightweight. Anyway, but so I'm just trying to give you an idea of percentile. So percentile is percent below. Percent below. So when they say P99, they mean 99% are below. They say P1%, only 1% of babies were lighter weight than my Emma girl at that time. So that's why they were nervous that she wasn't healthy. So anyway, so when they say here P99, they mean find the smallest 99%. So find the hip breadth, I can't say that word, breadth, the width, that for the smallest 99. So 99%. So let me ask you, am I trying to find, they're giving me a percentage, aren't they?
You're doing inverse norm.
So I'm doing inverse norm. Exactly, Eddie. Is everybody with Eddie on that? He's right. Right? They're giving me, so I'm certainly not trying to find a percentage. They're handing me the percentage. So I must be trying to find the thing on the bottom, the inverse norm. Right? We good there? I must be. Okay, so notice if we're talking about a curve, they're basically saying find the point. No, that's the wrong point. Find the point way over here that has 99% left of it. Find the point on this bottom that has 99% to the left of it. Right? Making sense how I'm determining that? Because P99 means 99 below. That's why I keep emphasizing below. It's percent left, which is perfect. That's just what we're supposed to have when we go to the inverse norm on our calculator. So we can just type it straight in. Just go straight to your calculator. Type in, since you want down here, type in inverse norm. You know where to find that in the calculator? And remember, it's left edge. So what's the left edge? That's the 0.99. You make it a decimal, right? Yeah. Don't we? We make it decimals, don't we? Yes. 0.99. I forget after a week.
Percentage. You put 14.9 for the mean.
Yeah, and then 14.9 for the mean. And what's the standard? 0.8. I think that'll do it. Just type that in right there. And we should get it. You guys getting it? 16.8. They want me to round to 1. Yeah, 1 decimal place. Other people getting that? Well, yeah, and here's why. Let me help with that. Because, so for us, it's all about, are we trying to find, let me go back to the picture. Good question. So it's all about this graph right here. You're either trying to find percentages or not percentages. Since they gave me a percentage, obviously I'm not trying to find a percentage. So I know I'm doing the thing on the bottom, the inverse norm. See how we're determining that? It's all about percentage or not percentage. They give you percentage, you're finding the not. They give you not, you're finding the percentage. Good. So that's the plan. So yeah, 16.8. So there we go. Other people are getting that answer, right? Anybody else verify that answer? Yeah? 16. What does that mean then? That means, remember, let me make sure this is real for y'all. What's the average, what are we measuring here? Oh, the average hip width. What's the average hip width for men? 14.9. That's the mean, right? That means the average man's hip width is 14.9 inches, but not everybody's average. There's above and below. People are above and below that on average by 0.8 inches. We're finding that we're saying if we make these seats 16.8 inches wide, that'll cover 99% of men. Do you see what we determined? That's what that 16.8 is. The average man's hip width is 14.9 inches. If we make the seats, this is what people do, manufacturers, they really do this kind of stuff. They want to make sure they make the seats big enough to cover most of the population. So if they make the seats 16.8 inches wide, they know they're going to cover 99% of all men. Thus, definitely all women. Make sense? On that? We good there? That's what we're finding. We found the 99% mark. There's still going to be 1% of men that cannot fit in that seat, but that's pretty good. All right, so that was number 5. Shall we do? Can I move on? Number 6. Assume that adults have IQ scores that are normally distributed, mean 98.1, standard deviation 18.5. So that's the average IQ. That's the average variation, distance from the middle. Find the first quartile, which is the IQ score separating the bottom 25%. Eddie, question?
No, I was in the help. I don't know.
You got it?
Yeah, I don't know.
So bottom 25% from the top 70%. Remember Q1, it's like a football game or basketball game into the first quarter. 25% of the way through the game. Right? So it's like a football game or basketball game, and the Q1 is right, here's the halfway. Q1 is right there. It's the 25% of the way through the game into the first quarter. Right? Q2 is second quarter, Q3 is third quarter. Right? So we're trying to find the mark right here that separates the bottom 25% of IQs, the bottom 25%, from the top 75%. So, they're handing me a percentage, right? They're giving me a percentage. So what am I trying to find then? The numbers on the bottom, the inverse norm again. Right? Is that making sense? See how to determine that? So we do inverse norm again. So inverse norm, go to your calculator. Inverse norm. Put in, now what are you supposed to put in the inverse norm?
0.25.
Yeah, the 0.25 because it's left. For this spot, how much is left of it? It's always to the left of it. 0.24. Or you could just always see whatever they say bottom. And they'll say that. In these problems, a lot of times they say whatever's, below or bottom, that's always left. That's what you want to put in. Did everybody catch me on that? That'll really speed you up. When they'll say below or bottom or smaller, that's always the left. That's what you want to put in inverse norm. Then the mean was what? 98.1. And the standard deviation, 18.5. Hit the button. Somebody got an answer? 85.6. It's always good to see if that's reasonable. So 98.1 was the middle. 85.6, a little below that. Seems reasonable to me. So that's the, if your IQ is 85.6, 25% of the people have a lower IQ, 75% have a higher IQ. 85.6. That's the Q1 first quartile mark for IQs. Is that good on that? Questions on that? I don't know if you can read my writing up there. We getting that okay? All right, you guys are so quiet. Let me know if there's anything we want to talk about. I'm going to move on. If you're good, I'm good. On to number 7. So the words are getting longer, but the problems are the same. Suppose that the sitting back to knee length, back to knee. All right, so how far, when you're sitting down, you guys are sitting down, how far from your back to your knees, that distance? Right? So like, if you want to sit in an airplane or bus or something, the leg room, basically. So back to knee length for a group of adults has a normal distribution, average, 24.6 inches, standard deviation. So, right, so they say when you're sitting down, so like if I'm sitting down, right, how far from here to here? From back to knee. So how much that kind of room is. The average is 24.6 inches. There's a standard. These data are often used in the design of different seats, including aircraft seats, train seats, theater seats, classroom seats. Instead of using 0.05 for identifying significant values, use the criteria 0.01, basically. Find the back-to-knee length separating significant values from those that are not even blah, 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 blah. All right, here we go. Find the back-to-knee length separating significant values from those that are not significant. Now what? That can be confusing, huh? So they're saying find the back-to-knee lengths separating significant values from those that are not significant. And what did they just say up here to use? They said, instead of using 0.05, isn't that what we usually use for significance? 0.05. They said on this problem, use the criteria 0.01, 0.01. So what they're saying is this. They're saying, look, people are spread out, how far from their back to their knee, how long that is all spread out. There's some kind of average, whatever that is, 24.6. The average adult has 24.6 inches from back to knee. It's all spread out, but we want to make seats on the airplane or train or theater, classroom, whatever, that go from the bottom 0.01 to the top 0.01. We want to make seats that cover everybody except the tiniest and the biggest 1%. That's what they're basically saying. Does that make sense? They want to make seats that'll cover almost everybody except the very biggest basketball player, 1% people, and very tiny, smallest 1% people. They want to make the seats cover everybody in between. That's what they want. Does that make sense? Well, that's what I did with the high 1% and the low 1%. Right? Those are percentage. That's a decimal version of a percentage, huh? So again, they're giving me the percentages. It's in decimal form. But they're giving me the percentages, aren't they? So I'm not going to find percentages. It's not a normal CDF. It's another inverse norm, isn't it? Does that make sense how I determine that? It's a little more tricky this time because they wrote it as a decimal. But that is a percentage. That's bottom 1%, top 1%. They want me to find those marks. Like, how small should we make what's the smallest and what's the biggest back to knee distance that'll go from the smallest 1% to the biggest 1% of all people. That's what they want me to find. So, here we go. Let's find. So we're going to find them one at a time. We're going to have to use inverse norm twice. Once to find the low number, once to find the high number. Let's start with the low number. So if we do the low number, inverse norm, what do we do first? We go left. So how much is left of that spot? 0.01. Yeah, that's 0.01. That's the part left of it, huh? 0.01. 0.01. Left, and what was this? The middle was 24.6. The standard was 1.2. Hit the buttons on your calculator. Somebody get a number there? 21.8. Round to one place. That looks perfect. 20, is that good? That's a looks like a reasonable number to me. 21.8 down here. 21.8. Now we need to find the big number also. How are we going to use inverse norm again? Because we want the numbers on the bottom again. Now, remember, when you use inverse norm, you got to put in left. So if you're at this spot with 1% above you, 99 is below you. So I'm going to put in 0.99 and then the same center, 24.6, same standard deviation, 1.2, and get an answer. Does everybody see why I did 99 there? Because at this spot, 99% are smaller than you, huh? If you're at the top 1% mark. Then 99, you're a basketball player probably or something, then 99% have a smaller back to knee width than you do. Right? Is that good? Somebody got a number there? I'm betting it's like, what is it?
27.4.
Yeah, that looks right. 27.4. So remember, whenever we use inverse norm, we have to take the area to the left.
That's why we did the 0.99.
That's why we did the 99, yeah. So for this spot, the left spot, there was 1% left of it. For the right spot, there was 99% left of it because there's only 1% above it. Inverse norm has to have left. That's how much is to the left. Tell you an answer. Is that good? So those are our two answers. So how do they want us to put them? It's kind of weird the way they do the words here. Let me see. I have to read it kind of carefully. What does it say? Back to knee greater than blank and less than... Okay, so it'd be less than the big one, right? Less than 27.4 and greater than 21.8. So between those two are not significant. Right, so if you're in that zone, you're more average. You're not significantly big or small. You're more average. Right. So using these criteria, is 27.0 significantly high? So what if somebody has a 27.0 inches from back to knee sitting distance? Is that significantly high? No, there 27.0 would be about right there, huh? So it's not. So it's in the somewhat normal range. I mean, it's kind of high, but it's not significantly high. It's not that top 1% or bottom. It's still in the middle zone, which we're calling that all average, or not significantly high or low. So we'd say no, or is not, I guess. Is not significantly high because it is inside the range of the values considered not significant. Does that make sense on that? So 27.0 would be right there. These all good? See how these are kind of the same. We'll do a couple more, but kind of the same thing every time. Is that making sense? All that's going to change in the next section is instead of this, they're going to say, we grabbed a group of 10 people, and we want to know where their average hip to knee length is. Then when they have 10 people, we go, oh, central limit there. That makes things go towards the center. And I'll show you, you just do one different thing in the formula. But we're going to use the same things on our calculator. It'll all be the same. We'll just have to remember, oh, that's a group of 10 people. Then we'll do one different thing. You basically divide the standard deviation by the square root of 10. That's all you do. Everything else is the same. So I want to prompt that for you. The next section is going to look exactly the same, except if individuals, like we did the individual numbers first off right here, it'll be groups of 10 people, or 20 people, or 100 people, or whatever, instead of individuals. Survey found that women's heights are normally distributed with mean and standard deviation. The survey also found men's heights, blah, 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 blah. Most of the, this is kind of interesting, most of the live characters employed at amusement park have height requirement, minimum 56 inches, maximum 64 inches. So if there's a height requirement at an amusement park for the live characters, minimum, maximum. Anybody ever done that? Have you been a live character at a park? Have you done that?
Me?
Yeah.
Been one?
Yeah, been one.
Oh, no.
Anybody been one?
One.
No. You've seen one, yeah. All right. Well, anyway, we have no live character actors here, huh? All right. So anyway, if there's a height requirement, minimum, maximum, because of the size of the suits or whatever, what percentage of men would meet the height requirement? What percentage? Find the percentage of men who could fit in the suits, meet the height requirement. If the height is from 56 to 64 inches.
I got a percentage already.
Wow. Okay. Well, let's hold up for just a second.
CDF?
Yeah. Does everybody see? This time, what are they asking me for? A percentage. So what am I going to use? The normal CDF, because I want a percentage this time. See how we know the difference? This time, they're not giving me a percentage. They're asking me for it, huh? See the difference? So we know, okay, so they're saying, these are all normal curve. So the 56 and the 64, that must be on the bottom. From 56 to 64. And they want to know the percentage between them. See what they're asking for? So we do, like y'all said, normal CDF. That's right. Normal CDF. And we put left edge, 56. Right edge, 64. That's the left, the right. And then, like always, standard or mean. Oh, we got to do for men, huh? Careful. Whoop, I grabbed the wrong one. Yeah, you got to, right. You got to be careful. I got to grab that one because we're talking about men on this one. So, right, I had grabbed the women one on accident. 67.9 and 3.2. Hit the buttons. What do we got?
11.14.
How many places do they want? 2 places. 11.14%?
That's us, yeah.
You've already moved the decimal and everything? Yeah. 11.14%. So it came out 0.1114 at first, and then you moved it up.
It came out 11369.
Oh, good. You rounded it. Yeah, it's all good. Perfect. Is that making sense? So only 11% of men would have heights that are basically short enough to wear those costumes. Right? Because so most men would not be able to fit in that costume based on their heights. Because it only goes up to 64 inches. What's 64 inches? 5'4", is that what it is? Yeah, 5'4", huh? Yeah, so any man taller than 5'4" would not be able to fit in the costume. So that's why we're only saying only 11% of men would be able to be in those costumes. Okay, now let's answer the question. Since most men do not meet the height requirement, it is likely that most of the characters that you see in the costumes are women, right? Probably they're mostly women. Makes sense statistically. Right? And then B is the same thing. How about we move on?
Well, B's not the same.
Does it be the same thing?
B's 50%.
Oh, you're right.
Always trying to move on.
I was just trying to move on. I'm just cheating you. Darn, you saw. Okay. Yeah, all right, try B. Try B.
So B would be.
So let me give you a chance. I'll give you guys a chance on your own. All right. Let me get a fresh screen here. Whoop, I don't have a fresh screen. Let me erase this. Well, I'll just do it over here. All right, so they're telling the height requirement are changed to exclude only the tallest 50% and the shortest 5%. Wait, the tallest 50% of men and the shortest 5% of men. What are the new height requirements? Okay, so they're giving me percentages. So I'm going to put that on a graph. I think drawing these graphs probably will help. So, tallest 50%.
67.9.
So that would be boom, boom, boom. This is 50%, right? Tallest. The plane was close, huh? All right. And shortest 5%. Shortest 5%. Everybody see how I'm coming up with that graph? Right, shortest is bottom. Right, whenever they say taller, bigger, that's always to the right, isn't it? And shorter, smaller, tinier, it's always to the left. So smallest 5%, biggest 50%. So and for men, this is the man graph. What's the middle of the man graph? It's 67.9, right? So this is 67.9, the middle of the man graph. So we already know that right there. We don't even need to do anything on our calculator, right? And then we got to find this number, though. So how do we find this number?
Invert norm.
Yeah, it's on the bottom, huh? So it's inverse norm. Inverse norm. And what do we put in first?
0.05.
0.05, because it's left. Left of that spot is 0.05, and then the middle, 67.9, and the standard, which is 3.2. And so we get a value.
62.6.
62.6, thank you. So this is minimum of 62.6, maximum of 67.9. They want this number and this number. Does that make sense? So they want to make new height rule for the, whatever we're doing here. I forgot what we're doing already. Oh, for the suits, for the outfits, for the characters, right? Then those would be the 2 marks. Is that good? Min would have to be, so min between 62.6 and 67.9 could wear the outfits, be the live characters. Questions on that one? This making sense? How you know which one you're doing? All right, I'll move on. Assuming you're good. You're quiet. I guess that seems good. All right, how are we doing on this? Number 9. Survey found that women's heights are normally distributed. This is getting to be the same every time. Survey also found that men's heights. Is this the same thing?
No.
Oh, an executive jet. It seats 6 with a doorway height of 55.7. Okay. Complete parts A through C below. What percentage of adult men can fit through the door without bending? All right, so I'll give you a chance to think on that. Are we good? So, what do they want from me? Are they asking for a percentage or not a percentage? They want a percentage. So according to my curve up there, what does that mean I'm doing? Normal or inverse? Normal, right? Because I'm trying to find a percentage. So whenever you're trying to find a percentage, you want to do the normal. Right? When you're trying to find a not percentage, that's when you do inverse normal. So, all right. So, trying to find a percentage. So, and a graph I think helps. What are they saying? What are they saying? The percentage of men who can fit without bending. Okay. The men, executive jet, height of 55.7. So 55.7 is the number on the bottom. How do I be right? It's not a percentage, is it? Right? So if it was a percentage number, then it goes up into the curve. If it's not a percentage number, 55.7 inches, it goes on the bottom. Right? You getting the hang of that? All the non-percentage numbers go on the bottom. And they want me to find what percentage that is. So what's in the very middle for men?
67.4.
Yeah, 67.4. Okay, and they want me to find this percent, the percent to the left of 55. Oh, wait, 55.7 is not to the right of 67.4, is it?
To the left, right?
That's a crazy graph that I've drawn there. Let me try that again. So I should have started with the middle. So the middle is 67.4. So where am I going to find what is 55.7? It's got to be somewhere over here. Lower, yeah. 57. And they want me to find the percent to the left of 55. Well, how do I know it's to the left?
Yeah, I was gonna say.
It's always to the left when it comes to.
Well, they might not. They might ask me for the right when I go to use the. Yeah, don't confuse two things. They could ask you to find to the right. The function will only give you left.
To the left.
So how do I know they're actually asking me to the left on this one? What in the words?
Because they have to fit through the door.
They got to fit through the door. They got to be shorter than that,
Okay.
right? Without bending. That's what it says, right? The question is, what percentage of adult men can fit through the door without bending? So they have to be 55.7 inches or shorter. Does that make sense? There's not many men that are in that zone, I don't think. But does that make sense? How I knew it was less, right? They want. So I think that's the main battle in these is reading the words enough to get, if they're saying bigger, smaller, left, right, that kind of stuff. So they're saying they want to know what percentage of men are 55.7 inches or shorter. That's what they want to know. They can fit through the door without bending. Can just run through the door, no bending. That's what they want to know. So am I going to do inverse or norm? Norm, because I want the percentage. So it's normal CDF. Okay, and what do you put in normal CDF? Exactly, good memory. Yeah, what's the left edge of that shading? Negative 999, or however many nines you want to do. Negative 999 is the left edge, isn't it? The right edge is 55.7. The mean is 67.4. And the standard deviation is 3.8. Is that making sense how I came up with that? So I'm wanting the percentage for this chunk of shading that is 55.7 inches or lower, right? People that are 55.7 inches or shorter. So left edge is forever left, isn't it? Negative 999, 55.7. Right? You just put it in, you put negative 1,000 if you want. You know, just some small negative number. And hit the buttons. And they want us to round to 2 decimal places. Probably a super small number. I'm getting 0.001037. You guys getting that? Mm-hmm. Move the decimal. That's a decimal. They want a percentage, right? So move it 2 places. Boom, boom. So 0.1038%. Round to 2 places, 0.10%. 0.10%. So that's less than 1%. That's 0.1%, isn't it? Not many men are shorter than 55.7 inches. Right? Just 0.1%. 0.10%. Very small amount. That makes sense. What's 55 inches? That's 4 foot. 4 foot 7. Is it 4 foot 7? 4 foot would be 48.
4'7".
4 foot 7.
Just well, actually, just over 4'7"
With the 0.7. Yeah. 4 foot 7.5. About. Yeah. 4 foot 7.7. Anyway, is that good? Does that make sense on that part? How about part B? Does the door design with a height of 55.7 appear to be adequate? Adequate for what? What are we trying to do? Honestly, I've lost context here. What are we doing? Why didn't the engineers design a larger door?
The door design is adequate because so many men will not be able to.
Yeah, it's only 0.10
What?
without bending.
The door design is adequate because the majority of people will be able to fit without bending? No, that's not true, huh? The majority won't fit. The door design is adequate because although many men will not be able to fit without bending, most women will be able to fit without bending. I don't think so. The door design is inadequate because every person needs to be able to get in the aircraft without bending. I think it's okay to bend. That's just dumb. That part's dumb, I think. I don't know. So, that's A, I guess.
So for this C part, we do.
Yeah, what's part C?
Inverse norm?
What? Yeah, right. Good job. Because they're giving me the percentage, huh? So it's
Then
inverse norm.
40, then the males.
40% of men to fit without bending.
Yeah.
Yeah, is that 40% left? Because when you ever go to inverse norm, you got to use left. Is that 40% the smallest 40% of men? Yeah, right. That's right.
Wait, I'm sorry to go backwards, but for the percentage of men who can fit without being is 0.10%.
Uh-huh.
How did you get that?
Yeah, so I did this normal CDF here.
Mm-hmm. That's the right answer?
That is, I think so. Unless, right? So that's what I got. Other people get that? I think so. Does that make sense? I did this normal CDF, and the left edge is 0.9. It just goes left forever. And then right, this is the decimal I first got out of my calculator. Then I just moved the decimal point 2 places to make it a percentage. And then I rounded it to 2 places. Right there. 0.10.
Okay.
That good? Yeah, so part C would just be inverse norm, right?
66.4.
Is that what it came out to be? 66.4 inches? Right? You want me to scribble that one out real quick? So part C, this one would be inverse norm. 0.4, because 40%, and then what was the average? 7.4. And the standard deviation, 3.8. Comes out 66.4? So if they made the door 66.4 inches, 40% of the men could just run through it. We good? On we go? All right. All right, here we go. A common design requirement, number 10, is that an environment must fit the range of people who fall between the 5th percentile for women and the 95th percentile for men. So it'll cover tiny women and big men, basically. Get the idea of that? So basically, a lot of times when they build things, doors, rooms, desks, whatever, one of the ways they do it is we got to make it small enough so that the smallest 5%, well, any woman down, except the smallest 5% of women, are big enough. And all the men it's big enough for all the men except for the biggest 5% of men. 95th percentile of men. Does that make sense? That's the idea. They're saying when they manufacture things, they like to cover everybody except the smallest women and the biggest men, basically. Try to cover you can't cover everybody, you know. There's always crazy small and big people. We can't cover everybody, but try to cover all except the smallest women and the biggest men. Smallest 5% of women, biggest 5% of men. In designing an assembly work table, the sitting knee height must be considered, which is the distance from the bottom of the feet to the top of the knee. So we're talking about sitting down, right? So if you're sitting down from the ground up to your knee, so basically, you know, how high they want to put a table on an airplane or something, or a desk where they should put the top. Well, I guess it is a desk because it's a sitting assembly work table. Okay. Males have a sitting knee height that are normally distributed, mean, standard deviation. Females have sitting, normally distributed, mean, standard deviation. Okay, what is the minimum table clearance required to satisfy the requirement of fitting 95% of the men? So if you want to fit 95% of the men, and then we'll go on and do the women thing too. So let's start with that. So if this table is going to fit 95% of all men. So let me give you a second. Can you figure out what that is? If it's normal or inverse normal? This is a pretty typical one, right? Yeah, they're giving me the percentage, so it's inverse norm, right? So it's inverse norm. And what's left of that spot? Would it help if I draw a curve?
Yeah.
So we have the bell curve. And they're saying, what do they want? So this is the men curve with the middle being whatever it is for the men. I don't even know. Males, mean is 21, so the average knee to bottom of the foot to the knee height is 21.2 for men. Anyway, they want me to find the 95% spot for the men. So that's somewhere way over here, isn't it? With 95% to the left of it, huh? Does that make sense what we're doing? So this is 0.95 because that is the percentage to the left. Then put in the middle, 21.2, the standard deviation, 1.1. Hit the buttons on your calculator. Oops. I'm getting, 23.009. So round to one decimal. So just 23.0? So 23.0 inches, 95% of men would be below that. So that would cover 95%, except for the biggest 5% of men. It would cover 95% of men if you made that table height come up 23 inches. Does that make sense? From the ground up 23 inches, that would cover 95% of men when they sit in that seat. their knees wouldn't be bumping the table. Is that good? Think it says what we're doing? And then down here, determine if the following is true or false. There's a clearance for there will certainly be clearance for all women in the bottom 5%. Is that true or false? So if you make this table, so the table height is 23 inches, which means it covers 95% of men. It will certainly cover women, the tiny women in the bottom 5%. Well, yeah. They're tiny women. Yeah, they're going to be smaller than big men. Yeah. Clearly. Right? And so the statement is true because some women will have sitting neat that no. False, no. False, no. True, it must be C. True because 95% for men is greater than the 5% for women. Yeah. Right? The top 95% of men is going to be higher up than the bottom 5% for women, of course. The author is writing this exercise. This is Triola, who wrote our book, who is writing this exercise at a table with 23.4 inches of clearance above the floor. What percentage, I guess he got down and measured his desk, what percentage of men fit this table? So if Mr. Triola, Mario Triola, wrote our book, if he's got a 23.4 inch clearance, right, from the ground up to his tabletop is 23.4 inches above the floor, what percentage of men would that cover? So what are we going to do? Are they asking me for normal or inverse?
Inverse.
What do they want? They want a percentage, right?
They want normal CDF.
So normal, huh? Because they're asking me for a percentage. Is that getting more comfortable? Is that good? So it'll be normal. Normal CDF. And for that you do what? Left, right. So, yeah, what am I going to do? Is that good? Maybe be... Okay, let's take a look at answering this question. So, I think a lot of the battle on these is being as real as you can with these. I think it's a lot easier. So make sure when you read these kind of questions that it's really real for you. What I mean by real is like, could you explain it to just somebody who didn't know stats? Just what is it they're asking? When they say the author is writing at a table with 23.4 inches. That means if the author was sitting at a desk and sat down at a desk, right? Just trying to be real with this. He sat down at a desk, his table, and then he measured from the floor up to the tabletop. It was 23.4 inches. And he's saying, the question is, what percentage of men fit this table? So you want to think, they're always asking you above or below. Basically, above or below. So just think, which one is that? Fit the table. Fit this table. Yeah, fit this table. Is that, how do you fit the table? If your knees are above or below? Below. They're basically saying below, aren't they? You fit the table if your knee height is underneath it. You're not NBA material and your knees are sticking above the table. Right? So then we just go, oh, okay. So basically it's a curve. It's a normal curve. And they want me to take the 23.4 number. 23. I put it down there. Why? Because it's not a percentage. So it's on the bottom if it's not a percentage. And they want me to find this percent below, don't they? Right? So the left edge, what is the left edge for that? Negative 999. Right? Negative 999. The right edge is 23.4. And now what about the mean and the standard? Well, this is for men. They said what percentage of men? So 21.2 and 1.1. 21.2 and 1.1. Hit the buttons. What is it? 99.7? Is that right?
97.70.
97.70. Thank you. So it comes out. First it came out 0.9770. Is that what it is? Then you moved it. Okay. And now they ask for women. Only thing that's going to change for women is they have a different standard deviation, a different middle and standard deviation. All the rest is the same. You still want women to fit under the table. You still want women to be below 23.4 inches. Their legs fit under the table. That's going to be, I think, virtually 100% of women, isn't it? What did it come out to be? Is it? Okay, yeah. That would be my guess. 0.99999, yeah. Yeah, all the women are going to fit into that table. Right? So do you understand what I did there? I just did exactly the same thing. I just put in I just did normal, CDF. I did negative 999, 23.4. You still want them to fit, the women to fit under the same table. But the women have a different middle and a different standard. 19.4, 1.0 comes out 100%, right? Is that good? Is that making sense on that? How we doing? Really practice making the words real for yourself. You know, that's really it. As you read those words, stop and make it real for yourself. Let's glance at number 11. Make sure I'm not leaving. Look at number 11 for a second. Make sure there's nothing crazy I'm missing. Some of the military aircraft use ejection seats designed for men weighing between 146 and 215 pounds. Women's weights are normally distributed mean, standard. What percentage of women have weights that are within those limits? Are many women excluded? So that's the same thing. They just want a percentage. So is it inverse or normal? Normal, because you want a percentage. They're giving you the lower and the upper right there. It's a piece of cake. Nothing special.